welcome the Director of Engineering at the Plastics Pipe Institute, Lance MacNevin.
Hello. All right, very glad to be here, and thank you to the organizers for having us here today. I'm going to be discussing plastic piping systems, some of the things behind the wall, supplying the traditional sprinkler head systems that we heard about lately. I do have a confession to make. I work in a basement office with no windows and no sprinkler heads, just from home. So yeah, we'll be discussing plastic piping solutions. My name is Lance. I work for an organization called the Plastics Pipe Institute, which is a nonprofit trade association that actually started way back in 1950 here in New York City. In the early days of plastic pipe, a few companies were pioneering plastic pipes, mostly polyethylene back then and some PVC, and trying to figure out how do we test this stuff? How do we predict the life? How do we do quality tests? So they actually formed an institute to write the original test standards to make sure that there was quality set in place and standards set in place for plastic pipes. So as you can see by some old document we have down below, we used to be based in New York City. The organization is now based down near Dallas, Texas. But we're a big, like I said, a nonprofit trade association made up of about 160 member companies. Those are the firms that make pipes and piping materials. They all belong to our institute. So we work on their behalf. So the outline of my presentation, fairly straightforward. We're going to be discussing pipe, and the good thing about pipe is normally it keeps quiet and stays behind the wall, and nobody sees it or pays any attention to it. You may think of it as boring that way, but to the pipe geeks like myself and a friend of mine, Mike Cuddy, in the audience, it's really fascinating stuff. So my job in my presentation is to try to make the stuff behind the wall that you never see and hear about to make it seem kind of fascinating. Anyway, here's the outline. First, we're going to quickly make the case for residential fire protection, but that's already been done by David and others here today, so I appreciate that. We'll give a glimpse into New York City Code compliance because we do have a few screenshots for the City Code, which does allow for these types of piping systems. Then we'll introduce you to the pipes. We call them CPVC, which is one type, and PEX, which is another type. And I'll even have some samples. My friend Mike will hand those around so we can take a look. We'll touch quickly on the design and installation process of how you design, focused on residential fire sprinkler systems. And then finally, just provide some good reference information for some other organizations you may want to know about and check out the websites for. One of the documents we'll be talking about here this morning is called NFPA 13D. NFPA, the National Fire Protection Association, and 13D is their design and installation standard for fire protection systems for 1- and 2-family homes. The latest edition of NFPA 13D is from 2019. As I understand it, the city refers to the 2013 version. These standards get updated very quickly, so there's always little changes happening in these standards. And every jurisdiction kind of uses its own iteration through time. So the first topic is very simply that residential fire sprinklers work. You've heard this already this morning, which is great because I get to reinforce that message. So just a few sound bites about this. And this first clip, or this first quote, is from a group called the Home Fire Sprinkler Coalition. And there's several different trade associations and groups out there that are in the business of promoting residential sprinkler systems. But their quote is, the best one I found, is that having a residential fire sprinkler system is like having a firefighter on site and on duty 24 hours a day. So that kind of gets to the heart of the matter right there, I think, except it's quiet. It's mostly hidden, mostly concealed. You don't even know it's there unless you actually need it. You've heard this already, that fire sprinklers can stop a fire in less than 1.5 minutes. That's the typical standard test fire that they use when they're qualifying these systems and certifying them for use. And I don't know if you heard this earlier, but in 90% of residential fires, one sprinkler head will actually extinguish, quench, put out the fire, control the fire, essentially. So we're going to be talking about a few different myths about fire sprinkler systems as we go through the presentation. But yeah, one of the myths up front is not all these heads are connected. They're not all going off at once. And in most cases, a single sprinkler head will put out the fire and is using 90% less water than if there wasn't a sprinkler system and we had to wait for FDNY to show up and used our hoses to put out the fire. So great water conservation, obviously a lot less damage being done as well when you put it out quickly and earlier. We saw the video already. And then the part that we don't talk about much, but the pipe behind the wall, normally these systems are being piped with a material called CPVC or PEX, which is actually going to be the main part of my presentation, which I will get to in a minute. But This slide right here will first introduce these materials. So these materials have been around for a long time. CPVC was first invented in the 1950s and has been used in commercial use for potable water since 1959 in the United States, and has been listed for fire protection systems since the 1980s. The other material we'll talk about, known as cross-linked polyethylene, or PEX, the flexible one, it was first invented in the 1960s in Europe. It's been in commercial use since 1972, and it's been listed for plumbing systems in North America since the 1980s, and for fire protection systems since the 1990s. So these systems are not new. I'm talking about fairly traditional technology that's been around for a long time. Unlike what we heard from a minute ago, these are the more traditional systems. But it's a highly standardized industry. You just heard this previous exchange back and forth about various NFPA codes and things like that. We have our own list of standards and codes that we'll throw our numbers around. And I have a lot of these in the presentation. I'm not going to read them all out loud. That would get really boring. But of course, it's all in the presentation. So if anybody would like a copy of this, please let us know, or maybe you can get it through CHCP afterwards. The first important thing to know, though, is that all these systems the piping systems themselves are tested, then certified and listed in accordance to a UL standard called 1821. So to provide a little more information on 1821, that's what it looks like there. It's a standard for safety for thermoplastic sprinkler piping systems. So all the systems we'll be talking about are tested and listed in accordance with that piping standard, which actually measures the pressure resistance, burst resistance, vibration resistance, all kinds of other physical properties of the pipe and fitting systems that are used to make the sprinkler systems. Don't want to get into too much detail there in the interest of time. A few snippets of the New York City Code. And again, these are from our friends at the Plastic Pipe and Fitting Association who gave me some of this information. So if you go to the building code for New York City, Chapter 9 in fire protection, tells you go to Appendix Q to read about fire protection systems. And from Appendix Q, if you can see the part with green highlight, it says that sprinkler systems shall be installed in accordance with NFPA 13D, which is the particular NFPA standard that applies to these kinds of systems. So we'll be talking about that more in a few minutes. We also got this data from PPFA that actually shows that there are a growing number of fire sprinkler systems in use in New York City. So that is good news. And of course, I think everybody here would like that number to be much higher. So hopefully after today, we'll be able to do something to make that number to continue to accelerate. To then introduce you to the piping systems themselves, the first one, CPVC, stands for chlorinated polyvinyl chloride. That's just its technical name. This is a high-temperature, rigid plastic piping system. These pipes are typically pressure rated all the way up to 210 degrees Fahrenheit, so they do handle pressure at very high temperature. Like I said, it's been around for many, many years, many decades. Typically, the color of this pipe used for fire protection is orange, so you may have seen that overhead in some buildings, although normally you don't see it because it's above the drywall or behind a wall, and it's normally invisible to people in the buildings. These piping materials, like the other one I'll talk about, are typically certified to the 1821 standard I mentioned, and also to a standard called NSF 61. NSF 61 is a standard for drinking water safety for piping systems, so that means these pipes are also approved for potable water pipe too. And the advantages of a material like this, obviously corrosion resistance, they're not going to corrode over time. They're affordable compared with metal piping systems, much less affordable, or much more affordable, much lower cost. To give you an idea, most of the pipes used in a residential system, less than $1 a foot probably for the material cost of the pipe, and then it might only be a couple hundred feet of pipe. And one nice thing for joining piping materials like this is to go together with solvent cement, which you may say, so what? But if we're going into existing old houses and adding new piping into them, if we can avoid bringing torches into these old houses with dry timbers, we can probably avoid some accidentally cases of setting the houses on fire as we're trying to add fire protection into them. So that's a good thing if we can join the piping systems without, the addition of fire risk of burning the house down during installation. Here's just some information on the listings for these pipes, but we don't need to talk about that now. The other piping material, which is a little bit of a newer material called PEX, cross-linked polyethylene. I don't have a really long piece here, but this pipe, as you can see in the picture, typically comes on coils, so it's obviously flexible. So for a lot of retrofit jobs, it might even be easier to work with because you can take long pieces of this, feed them through walls, feed them through holes and joists. It's a good material for retrofitting systems. So that would lend itself also quite well to retrofit of fire protection systems in existing basements. To give you a few pictures of what these systems look like as they're used in the purpose, the picture on the left is just showing a piece of pipe with different types of fitting systems with fire head connections. The picture on the right is actually showing some white PEX tubing. Typically, it's installed in a 3/4 diameter size with a pendant type head exposed. Normally, it's not left like that. Normally, after the pressure test is done, the drywall goes up, and then the head is all that's left to see. And normally, the pipe is above the drywall. Myth number one, if you can see up in the upper right corner, won't plastic pipe burn in a fire? Well, if you take empty plastic pipe like this and try to set it on fire in the table, eventually, yes, it'll catch fire and burn. But in a fire protection system, number one, it's full of water, and number two, it's above the drywall, which is a fire-rated material. So long before the fire and the heat ever gets through the drywall, the head has activated and has controlled the fire. So these piping materials actually don't get exposed to the fire if they're installed correctly and installed according to code. Some more information here about the PEX systems in terms of code compliance. The sprinkler heads, we didn't talk about those much, but most of the time, especially in residential units, people are using the so-called concealed sprinkler heads. So if you look overhead, you're not even going to see the sprinkler heads. If you're concerned about the aesthetics, normally they have a concealed cover, which is heat activated, and the cover falls off when it gets hot. We saw that in one of the videos earlier. So that's an example there. Mike's going to hand that around. And then some of the other heads are the pendant type and the horizontal sidewall. So if you can't get overhead to run your piping in the ceiling, then sometimes we just do it through the wall. And you actually can get special sprinkler heads that direct the flame out or direct the water out from high in a wall setting to extinguish the fire down below. So we have some samples there. And in this image here, it's showing 3 different types of heads mounted on the same board. The gray line with the dashes, that's kind of where the drywall would go. You would never actually have all 3 of them in one ceiling just like that, but that's just kind of an illustration of how they would look. The next section to touch on really quickly is on the design process, and I know we don't have much time here, so I'll try to be as quick as possible. But the design process is done in accordance with NFPA standards, and there's 2 different standards that could apply, but typically for 1 or 2 family homes, I think we'd be looking at NFPA 13D. So this slide is more about 13R, which is for more multifamily, taller buildings. But for 13D, this is the one that's intended to provide affordable life safety systems for 1 and 2 family homes. And it's really up to the authorities having jurisdiction as to whether or not a 13D design is suitable for these types of buildings. In my experience, it would be. So most of the information on this presentation is about 13D designs. Some of the neat things about 13D, as you see on the bottom, it does not require sprinklers in bathrooms, small bathrooms, less than 55 square feet, so you don't need a sprinkler head in every little bathroom, every little closet. The requirement is to have sprinkler heads in larger areas. And typically a sprinkler head covers an area about 12 feet by 12 feet, as per one of the drawings you saw earlier in an earlier presentation. Now, one thing I do need to point out is that there's 2 different ways of piping these systems up and supplying them with water. They're all wet systems. They're always going to be charged with water, but some of the systems are called standalone, which means it's just a fire protection system. You fill it when the building is new, and then you're probably never going to be flushing that water again unless there is some sort of an event. That's known as a standalone system. In a lot of cases, because of concerns about stagnant water or things like this, code officials will require backflow prevention valves and possibly even alarms, so that if that system ever loses its pressure and there's no water, an alarm goes off to let people know your fire system is not working right now. So the standalone systems are very traditional, but they have a few pieces of complexity to them in terms of extra equipment required at the water supply point. The other alternative to that is what's known as a multi-purpose system, also covered by the same NFPA codes. And basically what a multi-purpose system is the same pipes that are supplying the sprinkler heads overhead are used to supply the cold water plumbing in that space. We haven't talked about plumbing at all here today, but I'm pretty sure for all these basement conversions, they're going to need bathrooms, they're going to need kitchens with plumbing. So these piping materials can also be used for that application as well. And if the systems are designed with multi-purpose system, then it's the same piping network overhead that's also supplying the cold water. Which means the only way you could not have water for your fire sprinkler system is if you don't have plumbing water in the basement apartment. So it's probably not being occupied at that point. So there's a lot of advantages to a multi-purpose system. Less piping overhead, less complexity, and for sure lower cost. So these are very affordable life safety systems, I guess is the main point to make. I've got some slides with hydraulic calculations to show how the codes calculate your pipe length and your pressure loss. That's not for today. I've got some slides with drawings about showing different piping networks in the ceiling. That's not really for today. I do have some slides with pictures showing projects under construction. Pictures are always better to look at than pressure loss tables. Here we see some PEX on the left and CPVC on the right. And this is all it looks like, and then the drywall goes over it, and it gets covered up. And then you might see that concealed head poking through the ceiling or sidewall head poking through the wall. So that was meant to be a fairly rapid-fire version of the presentation. There's other organizations out there that have great information on their websites about design and the use and the effectiveness of these systems. So we refer you to these different organizations here, including our own. And with that, I think that brings me to a screeching halt. Sorry to keep you from lunch a little bit longer. Any questions from the panel?
Thank you. So I think one of the main reasons why we wanted to showcase this particular technology is around a lot of the trade-offs we've been talking about in basements between cost, which this could affect and be more cost-effective, and also headroom. So where we're coming up with trade-offs of whether or not a lower ceiling height is acceptable in a basement that's already being occupied, a system like this could help address that. So we're going to move along because of the time, but we just want to highlight some of the main kind of reasons for this particular technology. Thank you so much.
Thank you.